Hi, good afternoon, and welcome everybody. My name is Robbie Bullock. I'm the head of mission at the British Embassy in Berlin, and I'd like to extend a very warm welcome to all of our guests and participants today. We are really very happy to be co-hosting this event with the Association of German Offshore Wind Farm Operators. Katrin Jung, Stefan Timm, many thanks to you and your teams. And also I'd like to thank all of our speakers for making the time and offering us such an engaging program today, this afternoon. And finally, of course, thank you to all of you who are dialing in from Germany and from the UK and from elsewhere. This is the second of our joint Innovation Offshore series. Last year we looked at offshore wind and hydrogen, and today we are addressing how innovation in offshore wind sector can contribute to the recovery from COVID-19. Just to kick us off, I'd like to cover three very important issues. First one is climate change, secondly, industry, and thirdly, cooperation. So firstly, on climate change, of course, COVID crisis has presented significant challenges for our economies and for our societies, and this is understandably the immediate concern and priority. But the longer-term climate crisis, of course, has not gone away, and we must not allow this to fall down the priority list. Instead, we should be embracing the opportunity to address both challenges by investing in a green recovery. Well, both the UK and Germany are playing their part. Germany's COVID-19 package includes wide-reaching green recovery measures. And yesterday, many of you will have seen that the UK Prime Minister announced a 10-point plan for a green industrial revolution. The plan will mobilise over £12 billion worth of government investment across the country, and this is hoped to spur up to 3 times as much of that in investment from the private sector, all by 2030. Of these 10 commitments, offshore wind is listed as the first. Last month, the UK committed by 2030 that we would produce enough offshore wind to power every home in the UK, that we will quadruple our output to 40 gigawatts, and we would install at least 1 gigawatt of floating offshore wind power. Other points in this plan, which aims to cover the entire economy, include improving energy efficiency, particularly in buildings, boosting the production of hydrogen, using carbon capture and storage technology, and ending the sale of new petrol and diesel cars by 2030. That is much earlier than previously announced. And all of this builds on £5 billion already announced in the UK for a green recovery. But it doesn't stop with domestic policy. As hosts of the next UN climate conference, which will take place in Glasgow in November next year, we are committed to supporting a clean and resilient recovery globally. And alongside the UNFCCC negotiations, the UK will mobilise real-world climate action, bringing together governments, businesses, cities, and civil society to make progress towards net zero in all sectors. One of our objectives is this race to zero, the UN umbrella campaign that brings together the net zero commitments from a range of actors and different initiatives. So my call to action to those of you today who represent different businesses, academia, and investors, please consider joining this race to zero ahead of COP26. You can check out the Race to Zero website or ask one of my colleagues after this event. Thank you. Now, the second point I wanted to address briefly is industry. And I mentioned that we would be taking an all-of-society approach to tackling climate change. And industry, and I mean by that specifically the offshore wind industry, will be crucial in the transition to a low-carbon economy. In the UK, renewables last year made up 33% of our electricity mix, and wind power was 10%. Our offshore wind capacity is now 10 gigawatts. Well, we recognise that industry needs a strong policy framework, a clear steer of our intentions for clean growth. Well, the UK industrial strategy underpins our objectives here. And the offshore wind sector deal sees government and industry working together to drive growth in the sector. Our review of the existing offshore transmission regime aims to streamline the bringing of electricity on shore. My final point is around cooperation, which is absolutely essential. Last year, Germany and the UK together accounted for 85% of installed offshore capacity in Europe. German companies, including many of those of you who are with us today, have played a major role in the success of our offshore wind industry. So thank you. And given our ambitious expansion plans and the fact that the UK is one of the most attractive destinations in Europe for foreign direct investment, there will be significant growth opportunities for European companies who wish to participate in this further expansion. So both the UK and the EU will need to exploit the potential of the North Sea to achieve our net zero ambitions. We want to maintain an open dialogue with our North Sea partners and work together on projects, and of course continue to share experiences. We believe that the UK's continued participation in the North Sea's Energy Corporation is an effective means of achieving this. As our future relationship with the European Union develops, we are confident that we will find a way of continuing our cooperation in this area. I very much hope that today's seminar will identify further areas for cooperation, particularly on green recovery. And now I'd like to hand over to Stefan Timm, the Managing Director of the Association of German Offshore Wind Farm Operators. Thank you very much. And Stefan, over to you.
Robbie, for the introduction. Hello, everybody. A warm welcome from my side as well. As Robbie already introduced me, I am Stefan Timm, the Managing Director of the Federal Association of Offshore Wind Farm Operators in Germany. And I'm very happy that despite the difficult circumstances, we have managed to put together another joint event about offshore wind innovations this year. No question, 2020 is challenging, not only in terms of impacts on our daily lives and event formats, which is why we can only meet online today, but also in terms of economic development and energy market development. The corona crisis impacts the energy market and our entire economy in a way we would never have imagined. Large factories had to shut down completely. The demand for oil and gas declined worldwide, and so has the overall energy demand. No doubt, these are turbulent times. But even though the negative effects certainly overweigh by far, there are also positive things we can draw from the last couple of months. The crisis once again showed that offshore wind is a reliable energy source. We have managed to keep our turbines up and running during the entire time. Ursula von der Leyen recently said the Green Deal could be the motor for the recovery, and I couldn't agree more. We have to try and make the best out of the situation now. We cannot predict how much more damage the virus will cause, but we can at least seize the opportunities that arise to accelerate the energy transition and achieve our climate targets. As you all read today, the European Commission published the Offshore Renewable Energy Strategy. The mere fact that such a strategy has been drawn up shows how important offshore wind energy has become for our energy transition. According on the strategy, 300 gigawatt offshore wind energy need to be installed in the European Union to achieve climate neutrality by 2050. Offshore wind is expected to be the #1 source of electricity in Europe by 2040. The North Sea certainly offers the greatest potential for new offshore wind farms, which is why in our eyes it is absolutely no question that UK and Germany have to continue their close cooperation. We share the same sea, we share the same climate goals. So we obviously have to support each other in the best possible way. And we see many opportunities for cooperation. And the new idea of an integrated and international offshore grid is just one aspect that makes cross-border cooperation even more crucial. Also, the offshore wind market is already quite international. Some of our members operate wind farms in both countries, Germany and in the UK. The suppliers tend to be active also in both countries. Cooperation, therefore, is key and highly beneficial for both sides. I'm very happy to see such a large audience here in our virtual conference room today. Thank you all for dialing in. Now, let's look forward to interesting presentations and discussions about how our countries can contribute to a green recovery after the Corona crisis. Together, we will learn about innovations that can bring down costs and minimize the environmental impact of offshore wind farms. There are so many possibilities for future cooperations of Germany and the UK. With this said, I hand over to our moderator for today, Katrin Jung. She is Head of Business Unit Offshore at Vattenfall, and I'm proud to say, member of our BWO board. Katrin.
Thank you. I think now you should be able to hear me. Sorry for a bit of a delay. I'm very, very happy to be your moderator today. It's a very amazing day to pick today, because today there was also the launch of the EU offshore renewable energy strategy. Sorry, I needed to read that up because it's a long word. We know it as ORAS. And that was, of course, not planned because that was planned for another day, but it still happened today. So it's, of course, a very fitting day to have this talk here today. There are first maybe a few practical things I would like to mention, which is do a Mentimeter session after the first presentation. So those of you having your mobiles next to you, please be prepared. Then there's also a chat function, and you're free to enter questions there. I will have the pleasure to have the chat with Patrick Reichen after his presentation. So there you can only nudge me for questions or points I should mention. And then after the panel, we will have the chance to have more Q&A. So there you can enter your questions, and you can also vote on questions of others, which then will bring the questions of the others up, so they will also be picked. So just as a bit of a practical hint, because that's not possible in all of the other conference equipments that I was in. Yeah, having said that, you most probably have seen the agenda, and you have seen that we have a very interesting program in front of us, so I also don't want to spend too many words right now. I would rather like to hand over to Patrick Reichen from Agora. I'm very glad to have him here and have him present. I know that Agora is a very very well-known think tank in Germany. I think it's quite amazing how you are able to bring very complex and very heavy topics to a point where you can put them into 7 points or into digestible pieces. So I'm very much looking forward to your presentation.
Thank you, Katrin, and a warm welcome also from my side. And kudos to those who organized this event. I mean, to have it the day the European Commission launches its wind offshore strategy is just amazing, and it's very timely, because essentially we will be needing that at large scale. So let me just give you 5 key insights from my side as an introduction to this conference. First, a key insight: the climate or greenhouse gas neutrality paradigm changes the economic discussions everywhere. What do I mean with that? We had last year basically the European Union and the UK deciding they would become climate neutral by 2050 at the latest. Then we saw this year Japan, South Korea deciding that as well. And we know that this is part of Joe Biden's program, and we will expect that to be then officially US position as of the first quarter of 2021. And then plus, we had the astonishing announcement by the Chinese government that they want to become greenhouse gas neutral by 2060 at the latest. So essentially, all major economies, all major regions are now on track to greenhouse gas neutrality. And 30 or 40 years isn't much when you basically do the backtracking exercise. Essentially, if you want to be by greenhouse gas neutral by 2050, it means the market for fossil fuel technologies will shrink in the 2020s and be gone after 2030, after 2035. Because obviously those assets have a lifetime of at least 10, 15, 20 years. So you can't invest in fossil fuel assets after 2030, 2035 anymore. Otherwise, you're risking stranded assets. And this is why the declaration of the UK government to phase out diesel and gasoline cars by 2030 is exactly in line with greenhouse gas neutrality 2050. In essence, it means then those cars can be driven on another 10, 15 years and then they're gone. And I expect this to be the consequence all over Europe. Germany will take a few more months to decide upon that, maybe even a year or two, but we will see a ban of diesel and gasoline cars all over Europe in the very early 2030s. It also means that that we'll have a discussion on phasing out gas. So we are already basically, UK is very much advanced when it comes to coal phase out. This is now happening throughout the continent as well in the 2020s. Part of the higher 2030 ambition will be that all over Europe we enter a coal phase out within the next 10, 12 years. So what's left is then the discussion around gas. And that would be basically the toughest challenge because essentially it is about how do we replace gas in high temperature, how do we appliances, how do we replace gas in heating homes. All in all, it means in companies that are still invested in fossil fuel assets need to find a new business model, otherwise they're in a shrinking markets within the next 10 years and their business model is gone beyond 2030. Second, that paradigm of greenhouse gas neutrality changes a lot in the energy system. Essentially, it means we will be putting the power sector at the heart of the energy system. Currently, the power sector is around 1/4 of overall energy consumption. That will change dramatically. The power sector will rise. We did a study on greenhouse gas neutral Germany, and we found that power demand in Germany will rise by some 50% by 2050. So some 950 terawatt hours compared to the 600 that we currently have as power demand. Because it is obviously carbon neutrality is about electrifying heat, electrifying transport, electrifying parts of industry, and therefore replacing that with carbon-free electricity is the way forward to phase out oil and gas in those sectors. And then there's something left, and that's where you can't use electricity. You need it in parts of shipping and aviation for the fuels. You won't have electricity. It will be the same with steel and chemical industry. And there, essentially, it is about hydrogen. Now, hydrogen will also need to be greenhouse gas neutral, and that means green hydrogen, and that means, again, lots of renewable power is needed. So at the end of the day, the whole carbon neutrality, greenhouse gas neutrality approach and paradigm means we need lots and lots and lots of renewables. The old paradigm, let's do a bit more solar and then we can do a bit less wind, or let's do a bit more wind onshore, then we can do less wind offshore, or vice versa, doesn't work anymore. From now on, we need every terawatt hour of wind onshore, wind offshore, and solar we can get. The limit will be the space. The limit is not cost anymore. The limit is not the question whether or not this is kind of needed, but the key question is, how do we get all those renewables built up at that speed and that scale that we need for greenhouse gas neutrality by 2050? And every spot in the North Sea, but also onshore that we can get, we should take. Now, what does this third mean in terms of COVID recovery? Of course, the whole climate neutrality paradigm, the whole picture we're having now of the 2050 energy system is in essence a big investment program, nothing less. Basically, it means let's modernize our energy system within the next 20, 30 years. And therefore, it is a perfect match that if you're discussing recovery programs, that you then say, okay, let's invest heavily, and investing means investing in renewables when you talk about the power sector. The wind offshore plans of the UK are bold. 40 gigawatts by 2030, that is a word. The UK, the German plan of 20 gigawatts is something we could improve, to my mind. We've been putting in our study a 25 gigawatts target for 2030 in there. But that's not the end. We need more by 2050. For the German case, we have some 70 gigawatts. The European Commission has put 300 gigawatts in there. And we had the old studies for all over Europe. We're talking about some 450 gigawatts. So that leaves the UK and Norway to come up with those remaining 100 to 150 gigawatts of wind offshore. So there is lots to do to get all those investments on the ground. Wind offshore needs to be part of the game on both sides. One, for producing electricity and for direct use, and second, for producing electricity that then produces green hydrogen. The COVID recovery program, and it's important that we use the money that governments will spend wisely. A lot of talk is currently around hydrogen. A lot of money is flowing into hydrogen, but at the end, we need renewables to power that hydrogen, which means the whole hydrogen agenda needs more wind offshore. And that's what we need to get across also to governments, that whenever they talk about new money, we need to talk about additional auctions and additional sites for wind offshore. Now, there are some challenges. My fourth remark, there are some challenges that also the wind offshore industry needs to tackle. And let me put them out here and hope for a discussion. First challenge is we need cooperation across the North Sea for that. We need cables that go throughout the North Sea and then connect the wind farms with the different countries. And that's new. We don't have that yet. We don't have basically an offshore grid regulation system. Who pays for those grids? How do we connect them to a system that makes sense? And how should cost and revenue sharing be in such a system? That is new and that is needed, and it won't be, Brexit won't make it easier, I guess, but we'll need it. So it is the North Sea and the Baltic Sea states that will need to cooperate in this. And therefore, that is urgently needed also that governments cooperate there. There is, second, another cooperation needed here and mechanism, because wind offshore planning will need to have a look at where are those wind parks and whether or not they are distant enough from each other. Because if we plan those wind offshore parks too close to each other, then they will be stealing each other the wind, and we have lesser full load hours. We did a little study on that, and it turns out that this is currently not yet a problem. But once you enter those 300 gigawatts, then you do have the issue that we need to have careful plans on where do we put which types of wind parks and what do we need in terms of planning so that they don't steal each other the kinetic energy. And third, how do we do that with regards to hydrogen? Shall we have the electrolysis directly linked to the offshore park and then pump the hydrogen through pipelines to the country, to the land, or shall the electricity still be going through cables and then the electrolysis is onshore? The further we get from the coast, floating offshore, and that's what we'll need once we get into those 300, 400 gigawatts scenarios. The more it might be that the electricity cable is not the preferred option, but then rather we want electrolysis to be offshore with those floating wind parks. So this type of logic, where do we produce the hydrogen and how do we transport it, and what kind of infrastructure is needed for that, is, I think, something we now need to carefully come up with concepts, because that again needs infrastructure, needs governments to come up with solutions there. Essentially, also in discussions between Norway, UK, Germany, Denmark, Netherlands, to get a joint concepts, because of course every country is currently engaging in that electrolysis and hydrogen story. Finally, where do we get from here? I think what we'll need is not only bold plans for 2030 and 2050, but we also need, especially in the German case, a plan on how to speed up things so that we can already see results in the 2020s. There has kind of been that arrangement that during the 2020s not much can happen within Germany, and that we only get the high additions in the late 2020s towards 2030. I don't think that we can accept that. We need every kilowatt hour of renewable power in the coming years, because the coal phase out will be faster. The whole climate agenda will be up faster as we move towards tougher 2030 targets. So what is it that wind offshore can deliver by 2025? What is it that we need from spatial planning, from governments, that more is done in short term? That would be my question also to the scene, because I don't think that this slow motion process that we currently have seen on the German side will continue much longer. A year from now, we will need from the new government a real new push, so that then Germany and the UK both have bold gigawatts of wind offshore in 2030. So thank you. I'm happy for this discussion to continue.
So while I'm trying to come back, I can see that Patrick Reichen has already left, but you're coming back now. That's good, because I thought we will have a bit of a chat on it. Yeah, as usual, very, very interesting and very much to the point. I'm especially interested, of course, in the challenges, and I can really clearly see them as you described them, because it's not enough to put ideas on the table where we want to be in 2050. What we have as developers is rather that auctions are delayed, consenting is delayed, and we are moving slow. And then for the few tenders out there, we are fighting over it as developers. And then on the supplier landscape, we have problems with suppliers actually keeping up their volumes or even extending their capacity, because there's not enough coming their way at the moment. So it all seems to accumulate then towards 2030 for the time being, of course, because that's then the next target level, and then possibly the years after again. Do you see any movement or trend? Are you in contact as the think tank with European levels or with governments on what actually can be done to accelerate?
At least when looking at the German scene, I'm kind of hesitant. It seems like the economics ministry isn't pushing that much, and the BSH neither. They have their 2040 plans of 40 gigawatts, but it isn't that they want to speed up things by 2030. Now, I do think there is room. There's the nearshore potential, but I can't believe that there isn't also the option to do more offshore by 2030. And I think what we would really need is a roundtable of actors, of suppliers, of project developers, of those that would be building it. And how can we really speed up? And then put that ahead of the next government to the German economics ministry and say, okay, now new legislative period. I presume that the 2030 renewables target needs to be higher. And this is what we as wind offshore can deliver for that. Because the whole Renewable Energy Act that we're currently discussing in Parliament is not having the Green Deal as the base. And I expect that hopefully in December, maybe early 2021, Europe will decide that their 2030 target is minus 55% greenhouse gas reductions. Now that's 15 percentage points higher than previously. Mm-hmm. Essentially, it means faster coal phase out, faster renewables build out. You can't. There are not much alternatives there, and therefore we in 2021 need to discuss how we can do that faster renewables build out also throughout the continent, but also in Germany.
Yeah, no, that is. I'm actually seeing that we are running a bit out of time, but we have a question in the chat on grids. I would actually extend that a little bit, not only asking about German grid situation, but coming a bit back to your point on the need to also have then a cooperation in the North Sea on grids. So how do you see that developing, or what are you in contact there with other think tanks across Europe on how to do it, how to get actually the grids built, not only then on land, but also in the sea, but both of them then, of course, together in conjunction.
Mm. Well, actually, so far the whole bilateral grids, international grids were bilateral grids. So it was essentially negotiations between the UK and Norway, or between Germany and Norway, and then also between Germany and UK. And and the next step will really be need to be a multilateral negotiation on that. I think we need to go back. I mean, the whole idea of a North Sea grid was already there some 10 years ago. We would need to reactivate that, sketch out a map, and then invite them all to the table. I would see that coming now with the offshore strategy by the European Commission. They will be pushing that. It has also been a part of Germany's Baltic Sea program. So I do see that there are first moves on this, but again, there is nowhere this boldness that we need. And I'd say, just like the hydrogen people are now putting maps on the table with their grids, we need to do the same for wind offshore and the North Sea.
Yeah, thank you. And we will be coming back to the topic of grids then in the last presentation. But for now, I would like to thank you, Patrick, and then hand over to Sarah Marsha from Atkins. She will present about floating wind opportunities. Atkins is a global design, engineering, and project management consultancy, well known in the offshore space. And Sarah is a principal engineer that has been working with floating. So the floor is yours. Looking forward.
Thank you very much. Can you hear me okay?
Yes, you're there.
Thank you very much.
Hello.
So I'm just going to share my screen. And hopefully you can all see that as well. Okay, so thank you very much for having me. I've already been introduced, so I won't spoil that too much. Basically, what I'm going to talk to you about is floating offshore wind, some of the projects that we've worked on, and some of the opportunities moving forward. So just a little bit about Atkins SNC, so just so that you have a context if you're not familiar with us. So we've got over 45 years in the offshore engineering field. 15 of those years have been predominantly with offshore wind. We've been involved in over 60 offshore wind farm developments, and that includes over 385 fixed structures. About half of those are jackets. We've got 20 offshore substation designs, and 15 of those we've taken right through concept, through design, fabrication, and installation. So based on all that really good fixed knowledge, we've also been involved in over 11 floating offshore wind projects, and that includes all types of substructure design, so semi-submersible, tension leg platforms, and spars. And a total of 8 gigawatts to date of electricity generation is dependent on Atkins designs of foundations and topsides. So it's just to give you an idea of some of the projects that we are involved with. We are involved globally. We've got operational projects in China and Denmark, France, Germany, Holland, South Korea, Taiwan, UK, and USA. And it's just to give you a bit of an idea about that. So I'm just flashing this up so that you have an idea about some of the other things that we get involved with. We were one of the founding members of Friends of Floating Wind to support the industry very early on. We're involved in numerous amounts of joint industry projects, trying to accelerate the technology with regards to academic studies and collaborations with industry. And so we get involved with not just the engineering and the detailed design and fabrication, but the really early on kind of proof of concept as well, and everything in between. So I just wanted to give you that option. I realize that we haven't got much time, so I'm just going to rattle through this. So I realize I'm preaching to an audience that is, I hope, is really, really behind floating offshore wind already. But I just thought I'd list out some of the key benefits that I see of floating offshore wind. And the top one that I've got there is the deployment further offshore. We've already talked about talking about accessing the wind resource and actually going further offshore and having greater opportunity and going into deeper waters actually gives us a better ability to access more of this very much needed offshore wind energy supply. So floating offshore wind allows us to do that. And we can optimize those solutions by driving the modularized, standardized designs of those systems. If we're talking about large megawatts and gigawatts of capacity that we need to generate, we're going to need to understand those key fabrication assembly line procedures. So we're going to drive down those fabrication costs, but also it's going to change the way that we design, and it's going to drive things that allow us to rapidly assemble those substructures, whichever platform structure that you choose, in different locations in order to maximize the space that we've got. So the quayside space and those industry capabilities onshore is going to be critical, and it's going to change the way that the portside infrastructure is going to be working with the offshore wind industry as well. In terms of the actual technical performance of the system, you can optimize that system, and it requires, we've already mentioned earlier about sort of cross-country collaboration. There's a great need to collaborate better across the supply chain. So in that, I'm talking about looking at the system as a whole, looking at the moorings that moor the floating device, the substructure itself, and the wind turbine or offshore substation. We'll get onto that. But it's only through that holistic look at the whole structure and that we're going to find those opportunities to optimize the systems and reduce those costs. And I really do think that it is achievable through better collaboration and more openness of supply chain. So one of the key things about floating offshore wind, and I already mentioned about the port facilities, is being able to bring the turbine or device back to port in order to do any kind of like major component replacement. And that's always been seen as a brilliant way to reduce cost and risk by removing offshore operations and removing more of those operations of personnel offshore. But this does depend on the capacity to be able to perform multiple connections and disconnections of those moorings and transmission cables, and whether or not it's suitable to be transported in what kind of met-ocean conditions. So all of these factors do dramatically affect those floating offshore wind devices, but it is all achievable, and never so more so than now. And just a last point on that, a lot of the codes and standards, there has been a lot of movement within the offshore wind industry to get some specific codes and standards for the industry to work to with regards to key design criteria and things like that. A lot of them were adopted from offshore oil and gas industry operations, but there are still some out there that are based on the oil and gas industry, and there's a lot of room, I think, for removing a lot of redundancy and risk associated, which was predominantly based with having personnel permanently on these installations, and also the presence of hydrocarbons in high-risk environments. So they're not necessarily applicable for floating offshore wind applications. So I just wanted to highlight those opportunities to optimize floating offshore wind moving forward. There's people already have done a much better job about talking about the opportunities, so I won't repeat that. But I really do see this as, and I'm going to talk about Scotland in a bit, I promise, but I really do see this as a global opportunity to develop the offshore wind capacities. But in the short term, the immediate opportunities are looking at countries from a geological perspective, so countries that have very deep waters close to large demand centers. That would be a key application for floating offshore wind directly. But not only that, in shallow water applications, the floating offshore wind devices might actually be better and make financial, more economic sense if you're looking at things with very difficult seabed conditions. So something that would be with very sandy or very loose seabed conditions would be very difficult to pile, then it actually would be better to have a more of an anchoring mechanism. So you'd look at a floating application. So that there's challenges that could be overcome with a fixed structure that would actually be better than if it was floating. There's also the idea that getting energy to isolated islands, and I don't necessarily even mean geographic islands, but I mean locations that maybe have very little infrastructure associated with it or very high electrical generation costs already, being able to decarbonize and remove, for example, the use of generators by being able to deploy floating offshore wind farms in close proximity would be an absolute boon and would accelerate the development of that energy generation for that community. Others have mentioned about the electrification of offshore oil and gas assets, and I really do think that in the next few years, some of the immediate opportunities are not only with the large-scale commercial developments that we're looking to achieve, it's also with the decarbonisation plan for the North Sea in this aspect, where we're looking at oil and gas assets that are wanting to remove their GTs, but they need to get power from somewhere. And I think that floating offshore wind, both in local field development or in local more close proximity and private wire, potentially brownfield development on the oil and gas assets location could actually be really contribute to this story. And lastly, I've got on there, again, others have mentioned it, so I won't go on, but I really do support the idea that floating offshore wind in conjunction with hydrogen generation, either by providing the energy for the electrolysis or in combination with just energy generation and maximizing that resource. I really do believe that it shouldn't be either or, it should be looking at sustainable energy generation and maximizing that potential. So not ruling anything out in a sustainable way. So they're just the potential ones that I wanted to talk about. With regards to Scotland, so in Scotland, ScotWind came out, so that's fantastic. And the first point there, I've got 45 years of offshore experience. That's specifically in regards to the Scotland offshore engineering and experience, obviously with their oil and gas background and the supporting supply chain and manufacturing and industry development in the area. But just to recognise that there's a huge amount of transferable skills and marine infrastructure that's already in place that is currently serving existing offshore wind facilities and construction, but also I see that the energy transition is also a skills transition where we're not going to lose good experienced people that are doing fantastic jobs offshore. We're going to just retrain or transfer with existing skill sets. So I think it's an expansion rather than a removal. So just making the point, if those of you, if you're not aware, that Hywind Scotland project is the largest floating wind farm in the world, and the Kincardine project is currently under construction, and Scotland will become home of the largest floating offshore wind project in the world to date. And I'm very excited about that, but there are further opportunities globally as well. Specifically talking about ScotWind, I did put a link in the bottom of my presentation, but I realised that you probably can't access that through here, but that's the document with the Marine Scotland plan, and it talking about the 15 ScotWind sites that are up for lease and the total development capacity of potentially 26 gigawatts. And they've limited that to 10 gigawatts. And the idea in the first leasing round, and the idea there is to actually think about some of the aspects that have been talked about already, about not competition for resource in terms of the wind itself, but also things about protecting our marine environment and making sure that we don't overdevelop and don't have a sustainable energy generation at the expense of our environment. So I'm fully supportive of that. So in this guide on the right, you'll notice a wonderful coloured map, and if you're not familiar with bathymetry, I'm just going to explain that a little bit. So you've got the coast of Scotland, and the yellow to green you'll see is the shallower water depths, and that's what we would traditionally see in the kind of fixed water applications. And you'll see from the purple and the blue, that's prime territory for floating offshore wind development. So you can tell from the sites, it's a little difficult, I apologize, I'm not sure if you can see my mouse, but there are outlines of the sites for the ScotWind leases marked around the Scottish coastline, and you'll see that there are ones that are in shallow water applications that are totally suitable for fixed structures, but there are ones in much deeper water applications that the only option is floating, and it's the most economic suitable solution as well. And so you can see there's a combination of deeper water applications, and it really will benefit the floating offshore wind industry development. So just thought I'd share that positivity with you. And just to finish on some final points, I believe the future is floating. I believe there's opportunities to develop really innovative solutions regarding remote monitoring and control equipment, and to improve the service life of assets. We've already seen the developments of robotic technologies doing blade inspections and things like that, and drone inspections looking at offshore structures. We've also got, I do believe that autonomous vehicle for inspections topside. So we already do it in a lot of subsea applications, but I think we're going to see it much more in terms of topside facilities, basically to reduce the personnel risk of people going offshore and working at height. I do think there's going to be a huge amount of development of port infrastructure and the facilities to cope with that rapid increase that we're going to need. And it's going to change the way that we design these structures, and we're going to look at that rapid increase in modular assembly and the requirements associated with the commercial scale of floating deployment. I do think we're going to have a natural progression into floating offshore substations. It just makes sense. I can talk about that extensively if people want me to. But I do think there's working collaboration across the industries and countries to generate sustainable energy, not just for export, but for other demand centers, including offshore networked grid and also any other industries or facilities that require it. I think we shouldn't just be thinking about generating energy to put it back into grid. I think we should be looking at better collaboration and in terms of energy share and actually integrating it better with existing infrastructure. And finally, I fundamentally believe it part of the net zero targets and achieving them is having a minimizing the negative impact on our marine flora and fauna, improving biodiversity. And I think that floating offshore wind is absolutely part of that. So that's my whistle stop tour of floating. I didn't want to.
Thanks, thanks a lot. No, it's really fascinating, and I can hear in your voice how enthusiastic you are about it. So it was really nice listening. We will have a chance to ask you a few questions afterwards in the panel, and I already see a few questions coming in. But before that, we would like to move over to something a bit of a different topic. We are going now circular economy. And I would like to ask Anne Valenturf, I hope I pronounce your name correctly. If not, then you will correct me in a second, to talk to us about end of life, environmental footprint of assets at the outset of project planning. I think a very relevant topic as well that we start getting our heads around. So I'm looking forward to hear what you have, what you're looking into, what you have found out so far. You will need to unmute still. You are on mute. And you might need to be patient because sometimes it takes a little while. No, that would be interesting if we do that via chat. We might need some help, Natalie.
She is unmuted, but I don't know why we can't hear her. The speaker briefing was perfectly fine. We could hear her perfectly fine. We're trying to figure it out. Maybe let's go on with Martin first, and I try to figure out something with Anne in the background. Sorry for this.
Okay, thanks. No worries. So let's try to call then Martin on the screen to us. You will be talking about importance of innovative interconnection and the pooling of maritime regional resources. So the title. I think you will pick up very nicely from where Patrick Reichen and me already discussed on the topic of how to connect between the different countries and have solutions in place. And you are from National Grid Ventures. Of course, I think every one of us knows National Grid as the TSO, but you're then from the unbundled, or the part that is looking into other opportunities on the side. And I'm looking forward also to listen to you and hear about the opportunities that you're looking into.
Thank you. Can you hear me?
Yes, perfect.
Great. Thank you very much. Yes, good afternoon, everybody. A pleasure to be here. We operate a business in Europe and the US and have interests in this area through the fact that we own interconnector cables between the UK and France, Holland and Belgium. I'm building 2 more to Norway and Denmark. And we have offshore wind interests in the US as well as onshore wind. And we also are pursuing carbon capture and storage opportunities in the UK. And I mention that because it's relevant, because storing carbon in the sea, in the North Sea, is another issue that we have in planning what we want to do with the North Sea. I'm going to try and share my screen, just to give you some insight as to the challenges or opportunities that we're facing in the UK. Hopefully you can see that. And I'll flick on to, some of this has been covered already actually, but hopefully you will be able to see this diagram on the right hand side of the page in front of you. So in terms of accelerating the uptake of offshore wind, we're already at the sort of tipping point in needing to do something different. The picture on the right shows you what the situation will be like in 2050 if we carry on with doing what we're doing today. So
sorry, can you hear me? I at least cannot see your slides. I don't know if Natalie is able to help us, or if it's only me, then that's of course. There you are. Can you, Natalie, can you?
I think she can. No, I've got share screen here.
The slides for you.
I think I can do it now. Thank you.
Okay.
Yeah, it's coming. So I'm going to leave you.
Is that good? Yes, sorry, I'm showing a picture here of, we'll go back again on the situation we're facing in the UK in terms of reaching our climate change targets and installing offshore wind. So the picture on the right there shows you the congestion, the number of cables that would have to be coming into the UK to support our climate change ambitions. And that's 2050, but actually if you look at 2030, the picture doesn't look much better than that. So we're already facing a really big challenge in doing this in a much better way, just to service the needs that we have in the UK in terms of providing renewable power via offshore wind. You can see in the bottom right-hand corner where London and Suffolk and Norfolk counties on the southeast coast of the UK. Quite frankly, our politicians are not going to allow us to take this many cables through towns and villages and onto the UK mainland. We've got to a point where we have to find a better way of doing it. And this is our challenge today. We've had a very successful market, in as many people have mentioned before, in terms of installing offshore wind, but we're into a completely another phase as we go from 10 gigawatts installed to 40 gigawatts. So I'll run through these slides briefly so that we've got time for questions afterwards. Today, this is the way we do things. Every individual cable has an individual approval from our system operator to come on shore. And one wind farm and the next wind farm and our own interconnectors, we each have separate connections. We each will do our own planning. We each do our own construction. We do not integrate today. And all of the commercial and regulatory regimes are set up to support this method of doing it. And it simply can't carry on. We have something kicked off in the UK called the Offshore Transmission Network Review. I think Patrick mentioned there are various reviews going on about how to do this differently in countries in Europe, and to do it sensibly, we will need to bring these together, because the benefits of connecting the North Sea into a North Sea grid are in terms of flexibility and sharing clean power and doing this more efficiently are significant. So we will be moving to, hopefully, a situation where at least we'll start to deliver some integration. So by creating high voltage DC cables through the sea with offshore platforms which can connect significant amounts of wind, we will be able to reduce the amount of onshore construction work that's coming on. We will be able to, if we build them properly, provide flexibility in the direction that those wind farms can sell their power. So they could sell them to 2 different countries, maybe 3 different countries. This will increase the flexibility we have in Europe in terms of balancing, in terms of, I think it'll accelerate our ambitions to reach climate change. So it's quite easy to draw that on a diagram. And as we said before, the challenge of actually implementing this, technically, yes, but probably more in terms of harmonizing systems, processes, platforms, regimes, commercial arrangements, regulatory arrangements is a challenge. We are actively pursuing what we're calling multi-purpose interconnectors at the moment. So we have 3 connection points in the UK that we're developing with partners. And we think we could probably service around 12, 13 gigawatts of offshore wind by building cables between with our European partners and building offshore platforms and connecting wind to them. But as I said before, the regimes to support this, we've had very successful commercial regimes. So cap and floor has been used for interconnectors. Something called a CFD, contract for differences, you can use for wind, and we've had also we've had a process called offshore transmission operator process as well. They don't really all work together very well at the moment, and we'll need to we have to work together as an industry to amend on our side, just on the UK side, how those commercial instruments work. But hopefully brought to life a little bit there, almost the immediate challenges that we face in trying to find a way of building a better way of connecting wind. And the benefits of doing this on a European-wide basis are significant. We already have significant joint venture partnerships with our European partners. Trying to do this incrementally and not having consistent methods and standards and protocols and regimes, I'm not even sure I could say it would fail. It probably wouldn't even start. So I think, you know, if the question is how important it is for us to collaborate on building out and really harnessing the opportunity of the North Sea, then it's essential we do this together. And one of the other issues that we might want to touch on lately is the North Sea in 10, 20, 30 years' time is going to be a very, very busy place. It already is busy with more and more offshore wind and other developers like ourselves having our eyes on underground stores to store carbon. Spatial planning in the North Sea is going to be extremely important. And I think I'll leave it there. I got to unshare. There we go.
Yeah, thank you. Thanks a lot for an impressive picture with the 2050 connection towards it really doesn't look like it's the most efficient way to do it. Yeah, we have questions then after the last presentation, and we'll try to get in first and see if it now works with.
We try again. Do we have?
Yes, we have. It's a bit.
As long as you can hear me, I think that we're gonna have to run with it. So there might be an annoying buzz. I do apologize for all these sound issues. I'm really very sorry. Everything was working perfectly in the briefing, but yeah, not now, obviously. All right. So unless I hear from you, I'm going to assume that you can see and hear me. All right, and I'm going to make a start. So as introduced before, I'm Anna Venetov. I'm a Research Impact Fellow in Circular Economy and Offshore Wind at the University of Leeds. And I'm currently seconded to the Offshore Renewable Energy Catapult and working with the UK Department for International Trade to start to integrate circular economy into offshore wind infrastructure design, operation, and end-of-life management. And this work will feed into a forthcoming program by the Catapult as well, called the Circular Economy for the Wind Sector program. So offshore wind is obviously a really fantastic sector. It's very dynamic, and there's huge opportunities and ambitions. But perhaps because of that increasing scale and because of the first generation of wind turbines approaching their end of life, there's also a significant number of sustainability challenges that is now surfacing, such as the access to critical materials to sustain the growth ambitions, the limited experience, and a much higher cost than anticipated for the end-of-life management. And circular economy can help with these and many other challenges as well, to turn them into business opportunities instead. And that is perhaps, that is what I'll be speaking about today. So basically, first of all, I would like to step back for a moment and think about what is it again, the circular economy. So basically, it can be understood as the opposite of a linear take, make, use, and dispose economy. And circular economy has been defined in hundreds of different ways. But what they all have in common is a striving to make better use of materials, components, and products. And that, in my view, has to involve the minimizing of resources that we take from the natural environment, the maximizing of the waste prevention, and the optimizing of the economic, the technical, the social, and environmental values of materials and products throughout their consecutive life cycles. So when I say optimizing, then we're obviously optimizing for something, and that for something has been determined already a little bit in circular economy, and that is the fair access to resources of current and future generations for them to have a good life. It is about improving environmental quality in absolute terms, and it is about maintaining economic prosperity. And that can deliver real benefits as well for business and for communities, such as significant amounts of jobs that can be created and new business opportunities, while at the same time very substantially reducing greenhouse gas emissions. So this is a really great way to basically support the green recovery, in my view. So in offshore wind, we can create value with a number of circular economy strategies, such as outlined here in this framework. It is a draft framework, still very much open for your input. So if you are interested to share your views on this, then please feel free to click on the link here, assuming that the slides will be shared, to read the full article. And if you don't have access to CIWM, which many may not have, then please feel free to drop me an email, and I'm happy to share the article as well. So let's run through this diagram then. So we could save costs by using less materials, provided that it is safe, of course, in our components. And if we use less materials, then we'll eventually also have less waste. So we can also extend the life during which we use components via strategies such as repair and reuse and remanufacturing, and at the whole infrastructure level via strategies such as lifetime extension and the repowering. We can also close loops of material flows with recycling, or we can return materials in some cases back to natural biogeochemical processes in a safe way via landfill operations, and rigs to reef type constructions as well. So the trick in a circular economy is to proactively design whole infrastructure and components in such a way that we can maximize values from all of these different strategies throughout the life cycle stages of a wind farm. For those who are already a bit familiar with circular economy will realize that these are basically representing the 4 areas of circular economy strategies that are commonly defined in terms of narrowing and slowing and closing and integrating resource flows. Now, the final point I would like to make about this is that if we look at the strategies, then the narrowing and the slowing of flows has a far superior potential to improve environmental performance. And in the remainder of my presentation, I hope to spark some ideas about how we can develop business opportunities from this as well. So let's look at circular economy strategies at the whole infrastructure level. So these are lifetime extension, repowering, and of course there's decommissioning and the restoration of sites as well. So I have used academic literature here as an indicator for the extent to which these circular economy strategies may be considered at the moment in the offshore wind sector so far. And we can see that for decommissioning, there's already a fair amount of consideration. For repowering, it has taken off properly. Lifetime extension in offshore wind, not so much just yet. And if we were to do more with this, then we could create substantial new business opportunities, such as designing sites for multiple turbine life cycles to save the cost, because then we only have to, for example, invest once in the site development and in the foundations, and possibly in the towers as well. Other aspects where we could develop business opportunities is, for example, with the benchmarking of the best practice and knowledge exchange, and also removal services will require expert services as well. Do give me a sign if I'm running over time, by the way, because I can't, obviously I'm in full screen, so I can't actually see you. So if we move then to the component and the products level, circular economy strategies, then we can see that there's a lot of activities on the repair and the maintenance side, and all the rest of it is still to be developed very much. And there's really substantial business opportunities here in terms of product service systems in which OEMs would be selling the access to a component rather than the actual component. So it's about selling function rather than the stuff. And also, I want to highlight here that disassembly is a often not recognized, but very much an expert skill, which we need to develop. Because if we know how to take things apart in a good way, then we can enable better reuse and repair, remanufacturing, all of those things. It's really essential that we know how to do that. And it's not that straightforward as we may think. Just echoing here a point made before, that there's also substantial opportunity to develop new ports. All of this circular economy stuff will require development of new data system services. Again, a huge area of business opportunity there. So I have a few slides left, so feel free to let me know if I need to start shutting up. So basically, materials, circular economy strategies, a real mixed bag here in terms of dematerialization and waste reduction strategies. They are not applied yet in any substantial way within the sector, or at least I didn't find evidence of that within the academic literature on offshore wind. When we look at recycling, also very much still starting out, early days there. And there is a real substantial opportunity if we were to develop circular economy strategies here. For example, in terms of recycling, technology development, the operation of recycling facilities, testing of materials to make sure that end users know about, that they can trust in the quality of the materials that they can use again. And also, there's a demand here for developing design skills for minimal resource use and the prevention of waste as well. And that ties into the last step in terms of circular economy strategies. By no means the last to consider, because this is probably the most important circular economy strategy of all. That is the design. And when I look at the literature, then it would suggest that circular economy and actually, interestingly, sustainability was apparently not yet is not the norm to consider that at the design stage. Think about sustainability surprised me a little bit. May not be true, so feel free to tell me off. But for the circular economy, wasn't that much of a surprise. So where does that leave us to go to the conclusion? So we can see that there's action already on many circular economy strategies within offshore wind. And what needs to happen next is that we need to start to proactively design and plan for a circular economy at every life cycle stage. So we need to harmonize across life cycle stages, and that will require a higher degree of collaboration. Again, echoing very much what the previous speakers have said as well. And that will help us to maximize the benefits and create these new business opportunities, really make the best use of that. So what's coming next in my project is that we're going to co-produce policy recommendations to adapt decommissioning guidance. That is focused on the UK, but there's a very high potential to exchange knowledge there as well across countries. And we're going to co-produce business opportunities in a workshop early next year. If you want to become involved in our project, then please feel free to drop me an email. And I would really love to hear from you. And that was all for me. So thank you so much for your patience as well with my various sound issues. I hope that you have been able to hear this presentation, and I will leave it at that.
Yes, sound worked perfectly now, so that was all fine. So let's see that we get this in again. Yeah, I think we are complete now. There are some questions already in the chat. Maybe just one comment. I mentioned Mentimeter in the start. We will skip that because we have been listening to two interesting be able to fit that in, but that's very fine because we would rather want than spend time on a IT tool, I would say. So we are going into a bit of a panel discussion now. I would just like to ask first all three of you. We are talking about innovation and green recovery. Do you see changes that are connected to the green recovery already coming your way, or that you would want to come your way when it comes to the proposition that you made here? So be it the grid situation, be it floating, be it circular economy. Do you see something on the horizon that would actually accelerate and is maybe connected to the green recovery? Maybe we start with I start in my clock with Martin, if that's okay. Take this round, the gentleman first.
Yes. Yes, I think the clear driver in the space we're talking about now in terms of the green recovery is the sheer volume of offshore wind that is required to meet our climate change targets. I think the subsidiary question is, how do we do that most efficiently and most effectively, and how do we accelerate it if we could? Which would be great, because I do think, as I tried to highlight in my presentation, carrying on doing what we're doing today when we're increasing the volume is not tenable. And not all the innovation is technical innovation, I don't think. Some of the innovation has got to be business model innovation. It's got to be regulatory innovation. So, we will have to, the whole energy transition is throwing up lots of innovation challenges for us. Hydrogen, carbon, increasing amounts of offshore wind, different ways of doing it that Sarah talked about. It has a role to play in enabling us, I think, to move at pace and with efficiency. So, and I think it could hold us back as well. So I guess if you turn the question the other round, if we can't innovate, if we can't improve, we don't achieve these things, it will probably slow down the pace at which we can invest in the green recovery. So I think that's the way I look at it.
Thanks. Sarah, your view on what is happening?
Sorry, I was just struggling to get my mic off. I agree with what Martin was saying. I don't think it's just about technical innovation. What would I like to see? I would like to see I'd like to see the acceleration, but I'd like to see it not at the expense of things like neglecting the circular economy and the benefits that we now know from understanding sustainable development and design. We understand about protecting our environment. I think we can still accelerate and collaborate better and bring along all the knowledge that we've gained from other industries and work better to come up with a solution. I don't think it's an insurmountable challenge. I think it's possible. I just think we have to find better ways of working together and knowledge share. I very much, I share Anne's comment about not understanding why it wasn't sustainability wasn't included at the beginning, and I think back to sort of being involved in earlier sort of oil and gas developments, and when they were first sort of being installed, they weren't sort of thinking about the decommissioning of them, and that's very common now to think about actually the decommissioning, and that was built into the regulation and the license for being able to do it. So for me, it's about understanding the full life cycle and actually how it's impacted on by the environment and also the other surrounding industries. I don't know if that helps.
Yeah,
I still don't know. Sorry, do you pronounce your name N or An? Maybe just so that
both is fine. I go by whichever people feel comfortable with. In Poland, I'm Anya, apparently. So there you go. So I echo all of those points. And I guess what I would really like to see happening is that our government in the UK would actually integrate circular economy into their decarbonization plans. We had yesterday the launch of our 10-point plan, and it missed out completely the resource efficiency and circular economy aspects. I don't know where our government thinks that how we're going to build all of this new infrastructure and how we're going to get all of these electric cars on the road, because we don't have the resources, we don't have access to those resources, and we need a circular economy approach for that, especially if we want all of this low carbon infrastructure to indeed be low carbon. Because of course the mining and the processing of these materials is very energy intensive. And the only way in which we're going to get the real benefit from that is if we combine circular economy with all of those decarbonization plans. So that is what I would really like to see. So I echo the point in terms of collaboration across government and also across industry as well.
Thanks. We're gonna go over to a very specific question. It got 4 votes, so Sarah, that's for you. It's about cable behavior of floating foundation. So a bit of a switch of topics, but so the specific question is if there are experiences regarding cable behavior, so fatigue, when it comes to floating technology.
So yes, I realize. Forgive me for not putting my email address on my slides. That I don't know if they'll be shared, but I'm on LinkedIn, and I believe that the event was shared on. Please connect with me if you have any other burning questions that people want to ask me. So in terms of the dynamic cable, yes, it is an issue, is the short answer, but it can be designed for. So the key point is understanding the actual material properties of the cable itself to be able to design it for its through life and understanding the fatigue issues, including any kind of buoyancy aids or any sort of bend stiffeners and things like that. It can be designed so that the fatigue isn't an issue, but you have to have really good data about where it's going to be and where the touchdown points are going to be, because it's not just the connection points at the terminals or the facilities, it's where it is in whatever kind of lazy configuration to take up the slack of any kind of tide differences or head differences, but it's also the displacement differences of the dynamic performance. So you might have the cable, it might just be impacting on the seabed as well, and if that's on sharp rocks, that's also going to be a problem. So it's such a dynamic environment. You really have to have detailed understanding of it. There's lots of analysis that has been done and that is continuing to be done, and I believe that the cable industry is really trying to step up to those challenges, and they're really working on it. Is there still work to do? I believe so. Yes, is the short answer, but we can solve it together. I really do believe that.
Thanks. We're jumping topics a bit, but next one I would call up is then on the 70% rule, and that one goes to Martin again. On the well, what is your read of it, or what? How do you think that one can be solved? I see from your face that you know what it's about, so but maybe you explain it briefly.
Yes. So what it is that actually today at the moment, an interconnector has to dedicate 70% of its capacity to trading between 2 countries. So if we touch a wind farm in the middle, and let's say the wind blows 50% of the time, there's going to be an issue there. So this is a topic, a sort of regulatory topic in my mind. Why do we have this regulation? It will need to be modified for, I think, the majority of sort of designs that we can see are going to be relevant on the offshore network, because the wind will blow that amount of time. So it's a regulatory issue. I believe there's been a recent derogation from the EU on a particular site to allow this, to exempt the operator from doing this. So it's funny, I spent 2 hours talking to my team yesterday saying, well, I just assume that sense will prevail here, and if we really want to achieve what we're trying to achieve here, and we all agree that these are the right designs and efficiencies, then we'll be able to modify the rule here. But it still exists, and as at today, if I had to build one and make the economics work and restrict a wind farm to 30% trading on it, then that would not be sustainable. So it is an issue that needs addressing.
Yeah, main workplace with Vattenfall that is passing our wind farm, Danish Kriegers Flak. So, well, yeah, but it's a derogation for 10 years time. So not for the full lifetime of the asset, which of course doesn't make a developer very happy on that side. Yeah, but I think, I mean, there is a bit of a common thread here. I think also when we look back to Patrick Reichen's presentation, that this is really a big topic to tackle, how to come to 2050, and it needs a lot of upfront work now, thinking how can the system work in the long term, and that's going across all of our presentations, I believe, on be it the circular economy or be it how to think about floating, how to incentivize floating to start with, where to incentivize it, how long, and then of course the grids, connecting the grids as well. And I'm just wondering a bit again, and that's maybe more reflection and asking for your reflection. It requires so much know-how from us in the industry towards politicians to be able to put the right priorities in place. That these kind of roundtable discussions that Patrick Reichen was also mentioning, I think would be very necessary as a common effort in getting the priorities right, what to do first, what to accelerate, and what maybe even to slow down a bit, because you would first need to identify the solution. So I said not really a question, but I mean, this is of course a big societal topic to solve. Don't know, any reflections or comments on, do you see light on the end of the horizon of areas actually working well together, or things that you see where we can get some hope
I'd like
from
to
that?
jump in with some hope,
we
if that's
actually
all right.
bring the different pieces together. Bit of a creative
so
question,
there's 2
but,
points for hope that I have. Although there's a lot of negativity that's happened this year, and I'm not going to go into it because we're all very aware of the reason why we're on a video conference rather in the same room together. I've never before have I been so enthused by the industry in terms of the desire for it to progress and to succeed. There seems to be a massive drive, and it's due to the combination of industrial engagement from different industries and government support and incentives and maturities of technology and developments, just a collective willingness to achieve these, not just the net zero ambitions, but go beyond that as well. And I guess that is a real reason for optimism. We're not here trying to convince people that it's a good idea. Whereas I think maybe, 10 years ago we were saying, well, this is you should be thinking about this, please. It's like this is not about convincing people that it's a good idea. It's actually, no, this is the idea. How do we make it achievable quicker? And for me, that's an optimism. That's fantastic. The additional optimism was an openness for collaboration. I guess I come from different sorts of backgrounds in terms of industry and engagement. And there was a time when industries were much more siloed, and they were saying, well, you may do that in that industry, but that's not our industry, so we're not going to talk to you about it. Whereas never before has there been such a willingness to learn from additional industries and saying, oh, well, you do that better than us, right? Well, that's going to help us in the long run. We're going to learn from it. So there's the increased learning that we've got from the maturity of the offshore wind in terms of the fixed industry, but there's also additional industries that we can learn from. So I believe that there's an enthusiasm and a willingness like never before from government and industry, and I also think there's a willingness to learn and to accelerate it. So for me, that's an optimism. That's a positive.
Thank you. Thanks. Martin or Anne,
yeah,
anything
no,
to add?
I would agree. I was thinking as Sarah was talking of almost inserting the words, I've never been quite so busy as I have been in the last 6 months, which does sound, at the beginning of lockdown, I wasn't sure that was going to happen, but the amount of, I think, policy, progress, collaboration has been really significant. And I don't just talk about it in terms of just in the UK as well, with our European partners as well, with the enthusiasm to move on and work out how we're going to tackle the challenge in front of us. It's been fantastic. Now, I think realistically that is going to lead to a reasonable inbox of implementation issues coming out, certainly from the regulatory and commercial aspects, because we're trying to change what we do and make it fit for purpose for the energy transition. However, I still think that's okay if we get on with it, because we have to remember in our industry, projects are long projects. We won't decide, we're not in a rush today to work out what the commercial regime will be for a project that will be working next week or next year. So, there are a lot of offshore wind projects that are in the planning, construction, design phase that will be delivered as we're designing them today and probably towards the end of this decade. What we're really trying to get to is how we design a better system for the second half of this decade so that we can move as swiftly as we can, transition from the way we do it today to the way we need to do it and beyond. So there is some time, but we work on long time scales. So, we will carry on with what we're doing today. We will carry on making significant dents in reducing carbon emissions. And in parallel, we've got to work in designing what's fit for purpose in the future. So, I think we can do it. And these are sort of parallel tracks that we need to really all throw ourselves behind.
Thank you. I think we need to come a bit to the end. I would just ask, Anne, do you want to add something or have a
keep it short in the interest of time? I echo the thoughts from Martin and from Sarah and from you as well, Katrine. That we can see a real eagerness actually now to start learning across sectors. So for example, in my project, we're learning across oil and gas and offshore wind and onshore wind, and we're bringing all sorts of circular economy related initiatives in those sectors together. And there's a real sense of not wanting to duplicate what we're doing and actually effectively collaborating and bringing those solutions to market as soon as possible, which that's really great, and that's very much an international undertaking. Interestingly, I'm also alongside of this taking part in the EOLIS event, and I notice a real change there in terms of data sharing as well. And of course, for circular economy, it's absolutely essential that we share data across the various life cycle stages. And in 2009, I was at another event, and there it was very much like, no, this is our data and we're not going to share, we're going to keep it to ourselves. And now what I see is very much a sense of, oh, actually, if we want to do this stuff and if we want to benefit all, then we have to start to share data far more. And so I can sense that there's actually a sort of a cultural change apparently happening within the industry, which I think is fantastic. And I'm sure there will be a lot of benefit coming from that as well.
Thank you. That I think was a nice closure with a very hopeful round of what all is happening and working. With that, I would like to thank you as my panelists and then hand over for the closing words back to Stefan Tim.
Hello again. Can you hear me? Can you hear me? Hello? Okay, it should work.
Fine.
Thank you. I think we all agree that we today have learned a lot about exciting innovations and the future of offshore wind energy in Germany, UK, and even further. One thing is certain, there is a lot of potential, and if we move on in technical development and international cooperation, we have a realistic chance to ensure a secure and sustainable energy supply for Europe. We are coming to the end of this event now, and I would like to thank all our speakers for the interesting presentations, Katrin for the fantastic moderation, and last but not least to the whole Orga team for this event. And of course, thank you all for your participation, for being here today. Please feel free to stay for another couple of minutes. Find a nice virtual chair at one of our offshore wind farm tables and use the opportunity to connect with each other. Bye.